Rewriting expressions using power-reducing identities. So the goal in these problems is to get rid of the exponents. I would like to have an equivalent expression, but where there is no exponent. And that's really what the power-reducing identities are for. When I see example A, I see a tangent squared. I need to look up the power-reducing identity for tangent. Let's see, we have that one right here. Tangent squared theta, 1 minus cosine 2 theta over 1 plus cosine 2 theta. So how will I apply this identity? Well, in my problem, instead of having a theta, I have a 5x. And as long as I can see that clearly, all I really have to do here is replace what I have here, the left side of this identity, with the right side of the identity. They're equivalent expressions. And so it looks like I'm going to have a fraction, 1 minus cosine, be very careful, it's very specific, of 2 times as much as theta. My theta is 5x. And then pretty similar on the bottom, just with a plus, cosine of 2 times as much as 5x. Well, 2 times 5x is just 10x. And so on the top, I have 1 minus cosine 10x. And on the bottom, I have 1 plus cosine 10x. I don't really have any other way to simplify this thing. I've gotten rid of the exponents, and so I'm finished. Let's take a look at example B. Now this one looks a little bit more challenging. I do have an exponent to get rid of, but it's a fourth power. We didn't have any fourth power reducing identities, so we'll have to be a little bit more creative here. What I need to remember is that, well, cosine fourth x is really just the same thing as cosine squared x times another cosine squared x, right? When you multiply two items with the same base, you just add the exponents. 2 plus 2 is 4. So cosine squared x times cosine squared x, and that's useful because I do have a power reducing identity for cosine squared x. Let's remind ourselves what that one was. That's the one here in the red box. So cosine squared theta, the power reducing identity for cosine, 1 plus cosine 2 theta over 2. Well, applying that in this problem is very, very simple. I have cosine squared x is the only difference, so obviously I'll just replace the thetas with x's, and I'll have 1 plus cosine 2x over 2 multiplied by another of the same thing. Okay, so far so good. Now let's see. One thing that's nice about the 4 is it allows me to cancel out these two 2's. 2 times 2 is 4, so that all cancels out. All I'm left with now is 1 plus cosine 2x times another 1 plus cosine 2x. To further simplify this, I have a FOIL problem, so I should go ahead and FOIL it out. I'll have 1 times 1 is 1. The two middle terms are each cosine 2x's, so 2 cosine 2x. And then the last one would be cosine squared of 2x, cosine 2x times cosine 2x. Well, just when I thought I was finished, I'm not. I'm supposed to eliminate all the exponents, and I still have one left. It's not a fourth power anymore, so that's good. But I still have this second power left, which means I got to keep going. I need to use this cosine double angle identity again. And that's no problem. The front part is great just the way it is, so I'll copy all that down. No exponents there. And then cosine squared 2x, well, I can apply my double angle identity as long as I'm seeing this 2x as my theta. So I'm going to go over here to the right side, and everywhere I see a theta, I'm going to replace that with 2x. So what will that give me? 1 plus cosine, and then it's 2 times theta. Well, theta is 2x, so 2 times 2x would be 4x, and then all divided by 2. Okay, I don't have any exponents anymore. That's good. Is there any other way I can clean this up? Yeah, the last thing I can do here, I'm looking at this fraction I created down here at the end. If I distribute the 2 to each part, I will have a couple of like terms I can combine. So I have the 1 and the 2 cosine 2x, and then I'm going to get a 1/2, and I'm going to get cosine 4x divided by 2. I think I'm going to write that 1/2 times cosine 4x. just to make it more resemble the other terms in the expression. And then the only like terms I have are the 1 and the 1/2. 1 plus a half is 1 1/2, or 3/2. And so I end up with 3/2, 2 cosine 2x's, and a half times cosine 4x. There's no way to further simplify this, and so we're finished. This skill of reducing powers, taking something like this with the 4th power and rewriting it with these separate terms that don't have powers, this is a very, very significant skill in calculus. There are some calculus things that we can do with this, but we can't do with this. And so rewriting it in this format becomes very, very useful. Thanks for watching.